One of the most important components in electronic circuits are these, and they're known as diodes, and they come in many different shapes and sizes, and they have different uses. Now, diodes are very important. In an electrical circuit, they work like valves. They let the water, or in our case, the current, flow in one direction, and they stop it from flowing in the other direction. Now, how does a diode actually work? The most common type is known as a semiconductor diode. Now, semiconductors are materials that can have the properties of either insulators or conductors. And by mixing the amount of impurity, known as a dopant, we can control the way the semiconductor allows the current to flow. So in the typical semiconductor diode, we have something like this. Now, it's called a PN junction. We have layers of P-type material and N-type material. And with this PN junction, the diodes are given a very high resistance to the flow of current in one direction and a much lower resistance in the other direction. One important thing to remember is that diodes like this are polarized. If you can see, there's a stripe on one end. This stripe corresponds to the cathode or negative terminal. The non-striped end is the positive terminal or anode. And likewise, on the electronic circuit symbol for the diode, we have a triangle. This is the anode and the cathode, if you can see here. And remember, the current flows from the anode to the cathode. So because diodes are polarized, they have to be put in the circuit in the correct direction or they won't work. So we can think of a diode as an angry policeman managing a traffic jam. They make sure the flow of current can only go in one direction. And this is useful for protecting electronic components that get damaged when they're connected up to the power supply in the wrong way. Like when we put the batteries the wrong way around in a torch or something. There are many different types of diodes. These are two different types of Zener diode. Now, what happens normally, a diode can only work up to a certain voltage, and the voltage that the diode can reach is known as the breakdown voltage. But Zener diodes work so that when the breakdown voltage is exceeded, the current can flow in the opposite direction without damaging the diode. Now, these ones are particularly large Zener diodes. That is, they can handle a good amount of power. If we look at a smaller one like this, it's actually got a transparent case, and if you read the red numbers with a magnifying glass, you can actually see the breakdown diode. Another type of diode is this. Here's another example. These are rectifier diodes. Because a diode only allows the current to flow in one direction, by using a special combination of diodes, we can convert or rectify alternating current into direct current. And the other really common type of diode is the LED, or the light emitting diode. And as you can see, these come in many different shapes, sizes and colors. In fact, we can even get these, which don't really have a color visible to the human eye. These are infrared LEDs, and we use this in combination with a special detector in, for example, burglar alarm systems. Now, LEDs don't really have labels, but this, as you can see from the stars, is a standard 5mm LED, which is often used in electronic projects. LEDs, as with any diode, have a positive and negative terminal, and they need to be hooked into the circuit correctly or they won't work properly. So with an LED like this, there are two basic ways to tell which terminal is which. If you can see, there are two legs here. One leg is shorter than the other. The longer leg is the positive terminal or anode, and the shorter leg is the negative terminal or cathode. And the other way is, if you look at the head, the side with the cathode is flat here, and the side with the anode has a round shaped head. And lastly, we can get these. Now, if you can see, these LEDs are quite special. This one has 4 terminals, and this is an RGB LED. So by hooking this into a circuit with some variable resistors, we can get a mix of red, green and blue light. And the 3 terminals, we have 3 anodes, 1 for each color, and the long terminal, or the cathode, for the negative power supply. So we have 4 terminals, the 3 shorter legs, anodes for the red, green and blue, and the longer cathode for the negative power supply. Thanks for watching. Make sure to check out our other videos, and feel free to like, comment and subscribe.